This week, we are going to talk about static methods, scope, and access modifiers. And we are going to start with static methods. We have been using a static method since day one, and it is the main method. We've also used write, write line, read, and read line, and they are all static methods. They are part of the council class and the system namespace. Static methods do not require an object to invoke or call them. If you remember last chapter, we used the random number method next. And in order to use that method, we had to create a random object that called the method. And this is similar to what we did last week. So random is our class. We created a object that we called rand, and we set it equal to new random. Okay, so that gives us the class object. We use the class object, a dot, and then we have the method name, and in parentheses, we send it the maximum and the minimum values. Okay, so we use the random object to invoke next. And that is typically how you invoke methods. With static methods, you don't need a class object. Instead of using the class object, you use the class name. So write, write line, read, and read line are all part of the council class. So we use the council class name, a dot, and then the name of the method. Methods always have a left and a right parenthesis after them, even if you aren't going to send it any data. Okay, with write line and write, we always are sending data. But with read and read line, we don't. Okay, if you remember, it's just council.readline, and we include the left and right parenthesis. So we're going to talk a little bit more about creating a method. Specifically, we're going to talk about static methods. And developers quite often develop or create their own methods. Obviously, if there is a library that includes a method that performs the task that you want to accomplish, you would use that. But if there isn't a library method, then you're going to create your own. The syntax is you will have an access modifier, which can be public, private, static. Those are probably the three that are most often used. And we will learn more about access modifiers when we get into actually creating classes. For now, we are going to be talking specifically about static. Okay, and then we have a return type, return data type. We have the name of the method, and then we have to have a left and right parenthesis. And if the method requires data to run, inside the parentheses, we have to include a data type and a variable name for every single piece of data that the method is bringing in. Methods always begin with an opening curly brace, and they end with a closing curly brace. And then in between, you've got all your executable statements. We're going to look at a couple of examples. Here we have an example. This is a static method, and the return data type is int, short for integer. And the return data type matches what you have in the return statement. So if you have a return statement and you've got data after it, whatever the data type is for that data that follows return, that is what you have to use up here as the return data type. Then you've got the name of the method, and then in parentheses, you may have one or more parameters. Okay, you may not have any parameters. And if you don't have any, you just leave them empty. In this example, the name of the method is CubeMe, and we are bringing in one value. It's an integer, and we are giving it a variable name. So we are going to call it number. While we are in the method, that integer that we are bringing in is called number. And you can see all we're doing is we're multiplying it by itself 3 times, and we're returning that value. So if the number 2 is being passed to CubeMe, number is going to be 2, and then we do 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, so it's going to return an 8. Okay, and it's returning an integer. This next example, another static method, and it's not returning anything. So if you look, the return statement doesn't have any data that follows. If there is no return statement, or there's a return statement like this with no data, that means it isn't returning anything. Okay? And you still have to key something in for the return data type. So what you key in, if it is returning nothing, is void. Okay? The name of this method is full name, and it is receiving 2 pieces of data. The first one is a string, and we are going to call it first. So it's the variable name here is first. You'll notice there's a comma, and then the second piece of data is also a string. That is the data type, and we're going to refer to it as last. So anytime we are inside the method, we can use the variable first, and that is referring to this piece of data. And we can use the variable last, which refers to this piece of data. All this method does is it writes out the first and the last name with a space in between, and then it returns. Okay, and it isn't returning any data, it doesn't need to because it already wrote out what it wanted to do. So return data type is void. This next example, also a static method, it is bringing in a string, and we're going to call it phrase. And then what it's returning, well, it is returning something, you can see that, but it is not returning the full string. We are indexing into phrase at position 0, which is the very first letter. So that is what it is returning, 1 letter. And that is a character. So this returns 1 character. So even though it's receiving a phrase, okay, it is returning something completely different, just a single character. Okay, now this one is a little tricky. So if you look at it, the name is find max, so you can probably figure out it's going to look for the maximum. The parameters, we have 2 integers. The first is called N1, the second is called N2. And then you can see it's static, and it's not returning anything. Now, up here, I said if it's not returning anything, the data type has to be void, the return data type. And you'd either have a return statement where it returns nothing, or you won't have a return statement at all, in which case the return is implied. Okay, so what will happen, let's say that somebody calls find max and they pass the number 5 and they pass the number 6. So N1 is 5, N2 is 6. So how this is going to process is it's going to say, if 5 is greater than 6, okay, that is false. So it's going to come down here. If 6 is greater than 5, well, that happens to be true. So it is going to write out to the console that 6 is larger than 5. Okay? And then it's done with the if else, and it's going to hit this closing curly brace, and it will return to the place that called it, which is where all programs return. Okay, so this is kind of an implied return. This is explicit because we say return, but they do the same thing. And we're going to take a look at some other examples because I think this will be helpful for you to kind of understand how you can code static methods with your main method, okay, all in the same class. So here is a longer program. So you can kind of see how this works in the context of an actual program. And so we have our main method, and this is the main method, and it is inside the program class. Now the program class starts here, but it does not end until down here. So below the main method, we have another static method called find max. And below find max, we have another static method called find min. And then we have another static method called cube. So in addition to the main method, we have 3 additional static methods. Now, these static methods will not run unless they are called or invoked. Invoking a method and calling a method are the same thing. So in this program, it says enter an integer -1 to end. So we're going to read in a number. As long as it is not a -1, we're going to read in another number. So the first number is stored in the num1 variable, and the second is stored in the num2 variable. Okay, so it is helpful to play computer to understand how this works. So let's say that for num1, they entered 10, and for num2, they entered 17. Okay, so those are the 2 values that they entered. Okay, so here we're calling find max, and we're passing it num1 and num2. Num1 represents 10, num2 represents 17. Okay, so we come down here to find max. We are bringing in the first value. We call it num1 up here, and it's called n1 while we are in this method. So while we are in find max, number 1 becomes n1. Number 2 becomes n2. And that's only while we are inside the find max method. Okay, so then it says if n1 is greater than n2, well, 10 is not greater than 17. So come down here. If n2 is greater than n1, yep, 17 is greater than 10. So it's going to write to the console. Okay, and then it's going to hit this bottom curly brace, and it's going to return up here. When you are returning nothing, there is no assignment statement. Okay, you don't have to have a variable on the left and set it equal to find max. Okay, because find max doesn't return anything. Find min is the same, right? So now we are back up in our main method and we are back to using num1 and num2. Okay, so we are calling find min and we are passing num1 and num2. So we come down here and in our min method, while we are inside this method, num1 becomes n1, num2 becomes n2. Okay, and so then it says num1 greater than, or n1 greater than n2 is 10 greater than 17. No, it does not. Is n2 greater than n1? Is 17 greater than 10? Yes. Okay, so then it prints out that n1 is smaller than n2. And again, there is no return statement, so that when it hits this ending curly brace, it is going to go up, back up to where it was called from. And we are no longer in the find min method. So now we are dealing with num1 and num2 again. And then we have another call. Okay, we're calling cube. But you're going to notice this is a little bit different because we have an equal sign. And then we have a variable, an integer variable that we're going to store a value in. So that tells me that cube is returning a value, and that value is an integer. And we're going to pass num1 to cube. Okay, so we're going to pass the value 10. So we're going to come down here. And while we're in the cube method, num1 just becomes n. So n is 10. So we're going to return 10 times 10, 100 times 10, 1,000. It's going to return 1,000. 1,000 is an integer. Where does it return that? It returns it to where it was called, which is right here. And we're going to store that 1,000 in result 1. And now that we're back up here, we are dealing again with num1 and num2, but we also have a third variable called result 1, and that is 1,000. And then we are writing out num1, which is 10. 10 cubed is, and we've got result 1, 1,000. And then you'll notice that we are calling cube again, but this is a little different. We are not using an assignment statement. When it returns the value, it returns the value to here, which is inside a write line. So instead of storing that returned value, we're just going to print it out. So how this works is it's going to say console.writeLine. So it's going to write to the console the value that is in num2, which is 17. So it's going to say 17 cubed is, and it is going to pass num2 down here to cube. Okay. And so now n is referring to 17. And I'd have to get my calculator out, but it's going to return 17 times 17 times 17. And that value is going to be printed here. And we are not storing the value. So there is no result 2. It's going to print it, and then we're done with it. At the very bottom, it's basically asking them for another number or -1 to end. We read in a new value for num1. And as long as they didn't do a -1, we're going to get another number for a value for number 2 and go through the whole process again. So here is another little example, and I'm just going to focus on the methods here. So here we've got, let's see, it looks like a little math helper program. And we're going to display a menu. Okay, so we've got several static methods here. We've got main. We have a math menu, which is static. We have a multiply method. We have a divide method. Okay, and they are all static, so we do not need a class object to call them. And these are all in the same class. They are all part of the program class. So we don't have to prefix with the class name. Okay, we can just use the name of the method. If you remember when we were using write line and read line, we were in a program class or whatever you called your class where your main method was. And when we're using write line or read line inside of this class, council is a completely different class, which is why we have to prefix with council here. But we've got math menu, multiply, we are all in the same class, so we don't need to prefix. So here we're writing out, hello, I'm here to help you with your math, and we're displaying a menu. And here is the menu. Please make a selection from the menu. It's going to have 1 for multiplication, 2 for division, or 3 to quit. So they are supposed to enter numbers. So we are reading in the integer. Okay, and I am using console.read, so it's going to retrieve an integer. I use read line to get rid of the new line character in the queue, and I am going to convert it to character and return it. So my return data type here is character, because this is where I'm converting it to character. We didn't pass anything to this math menu. The purpose of this menu is to retrieve a 1, 2, or a 3. Okay, and that is what it does. So you'll notice that there are no parameters here, but you still have to have the left and right parentheses. And the other thing I want you to take note of is that you don't put void in there. Void is only used for a return data type. Void is not a parameter. Okay, it is not an argument that you pass. So we only use that over here when the return statement doesn't return anything. So we've got our math menu. And then multiply and divide are very similar. So we are going to send 2 numbers. They happen to be 2 integers. We're going to calculate the correct answer. And then we're going to ask the user, what's the product of the first number times the second number. We're going to read in their answer. And we're mean, so we're going to force them to give us the correct answer. So we're going to say, oops, that was incorrect. And then we're going to ask them again, what is the product? And we're going to read in their answer. They're going to stay in this loop until they give us the right answer. Okay, so once the answer is correct, then we display great answer. And we kind of do the same thing for the division. We calculate the correct answer. We ask them, what's the answer of this number divided by that? Read it in, and then we're being mean, and we're going to keep them in the loop until they give us the correct answer. And then we give them some positive feedback. Up here, we declare a couple of numbers, and we are declaring a random object. And then you'll notice that we are in a little loop. And so it says while input doesn't equal a 3, and this is a character. Okay, it's got quotes around it. And you'll notice here's character input equals math menu. That's when we displayed 1, 2, or 3. And we converted it to character here. And this is where we're checking. So as long as they don't want to quit, we retrieve a random number. In this case, it is between 10 and 19. And here we are retrieving another random number between 1 and 9. And then we're checking the input again. If it's a 1, we're going to call multiply, pass it the first and second number. Otherwise, we're going to call divide and pass it the first and second number. Okay, and multiply and divide, once it has those numbers, it's pretty self-contained. Neither one are returning anything. They're basically going to ask for the answer, give them feedback if their answer is wrong, and give them feedback for the correct answer and return. Okay, and then at the bottom of the loop, we are displaying that menu and asking them for their selection again. And they have total control of whether or not they are going to exit out of the loop. And you might think, well, what happens if they do like a 4? If they do a 4 or something like that, it's not going to exit the loop. But it's not a 1. So if they do any other number, it's going to go into divide. Okay, so that would be kind of the default. So that is the first set of programming examples. Now we're going to take a look at scope and visibility. So scope is actually super important in programming because it affects where the program can see a variable and where that variable can be accessed. So kind of where that variable lives. A variable scope is determined by where it was created. And there are 3 different levels of scope. There is class scope. So if it's created at the class level. There's method scope, where it's created within a method. And then there is block scope. And a block is, in between an opening and closing curly brace. So class level scope would be any variable declared in a class outside of a method. And when you declare a variable outside of a class and outside of a method, it's typically called a class property or a class member. And we will specifically be looking at this in chapter 9. And any variable created above the main method within the class has class level scope. Variables with class scope can only be accessed with class objects. So the syntax for creating something like this would be the class name, the object name equals new class name. Okay, if you wanted to access a variable created like this, it'd be the object name dot variable name. And I do have an example. So this should look familiar to you. Public class program. I think ours sometimes will say internal class program. But here I have created a variable above the main method. And the variable is a string, and I set it to string empty. And then in the main method, in order to use this variable, I have to create a class object. So I have to say, program is my class. I have to give the object a name, and I have to say equals new program. Who is your favorite cartoon character? If I want to fill in name, I have to use my class object dot, and then this class variable. Okay, so that is how I would access something with class scope. And the key point here is that the name variable is visible anywhere inside the program class. So if the program class had additional methods below main, okay, like some of the examples over here, right? We have additional methods below main. Any variable that is declared within the class, that's a class variable, those methods would also have access to it. Okay, and it would be accessing it the same way. You have to create a class object, use that class object dot and the variable name. And we are really not going to be dealing with class level properties or members until we get into chapter 9. Method level scope is basically any variable declared within a method. And method level scope means that you can only use the variable within that method. So here I have a little method called print. Okay, and this is another static method. It's not returning anything, and there are no parameters being passed. Okay, and so here I'm just indicating this is method level scope. I have a string variable called name. I'm setting it equal to Shaggy, and I print it out. Shaggy only exists inside this print method. Shaggy does not exist anywhere else. The method print is visible anywhere inside the class. If there are arguments that are being passed, those are visible inside the method. And if I was to return something, that return value is going to go to where the method was called. Okay, but the thing to remember is if you create something inside a method like this, you can only use it in the method. If I wanted to use Shaggy somewhere else, I would have to return Shaggy. Okay, so if I decided I wanted to use Shaggy, let's say in the main method, at the bottom after I did the right line, I would have to say return name. Okay, and then I would also have to change the first line of the method, right? Because I am no longer returning nothing. So here's my method. Oops, let me see, I gotta copy it. All right, so here is the method as is. And if I do return name, now I'm returning something and it is a string. So I would have to change that. Okay, but if I don't return name, I can't use it anywhere but in the print method. Block level scope limits where a variable is known even more, because if you create a variable inside a block, that is the only place it can be used. And a block would be inside an if statement, inside a for loop. Okay, so those are the only places where we are using curly braces. So here is an example of block scope. When you are inside this if statement, if you have a string, a variable called name, this is only going to exist inside this if statement. It does not exist anywhere else in the program. So block level scope limits where a variable exists even more than method. And method is more limiting than class. Okay, so here are some additional examples. And I color coded these to help you guys out. And so this is kind of the full blown program. What we're looking at before was kind of a subset of it. So we've got a class called scope fun. And there's a couple variables up here that have class level scope. We've got name, salary, and age. Okay, and so why don't we write these down? So class scope, everybody knows about. So we have a name, Scooby. We have a salary, 10,000, and age is 30. Okay, then we get into our main method. You will also notice we have a print method. So we have two static methods here. In our main method, we are setting first round to true. So the first time this runs, it's going to go through, it's going to be, true. So it's going to run through this section of code that is pink. So this is illustrating block scope. So going through here, first round is true. We're going to execute this code. So we're going to write out block level scope. And now we are setting name to Scrappy. And you're like, how can that be? We already have name. This is going to temporarily override this. Okay, so right now within the block, so this would be within if block, the name is now Scrappy. The age is 5 and the salary is 1,500. So when it writes this out, it will be writing out these variables because we are inside the if block. And now we are setting first round to false. And then we execute the line below the if block. Okay, so once we're out of the if block, these values do not exist anymore. But the class variables do exist. They are still living in the program. So it's going to print out class level scope. Okay, and then you can see we have scope fun, which is the name of our class. We're creating a little object called person. And then to write out the name, the salary, and the age, you can see we've got person.name, person.age, person.salary, and it will print out Scooby 10,000 and 30. And this particular program is not calling print. So it's not executing this, but if I was to change this, which I can, and we can have it call print. Oh, actually it calls print up here. I missed that. All right, so we'll bring this back up. All righty, so here is where it's calling print. And so at this point in the program, we have the class level scope variables, and that's it. So it calls print. Print would know about Scooby, salary, and age, okay, because it has access to those variables. However, if it did something like this and created its own name, age, and salary, while we were inside print, those are the ones that we would use. So if we're inside the print method, our name is Shaggy, age, and salary. So that's what it would print out. But then once we return up here, those values are gone. They are actually destroyed. And we are left with Scooby's salary and age. And I will copy this and we can play with it a little bit more. Let me zoom out a little bit. I'm going to pause this while I get it into a program. Alrighty, so I'll run it this way so you can see that it in fact does work. Okay, so first it called print. Print created those variables inside the method, and so the write line used those variables. Okay, and then we went into first round, which created this block, these block level variables, and that's what it used. Okay, and then we went to the bottom of the main method, and all that was left was those class level variables, and that is what it used. So if we came into print and we changed it. Okay, so let's say we wanted the class level variables first. Okay, we could kind of do the same thing that we did here. Right, we have to create a little object. And I am just going to copy this. Okay, because we have access to those variables, we can print them out just like we did there. So let me get rid of this one and we're going to run it again. All right, so here is the first print where it's doing the Scooby, the age. Okay, so that's this print. And then it prints out method level scope with the Shaggy stuff. Okay, etc. Just so you know that, yeah, this class level can be accessed anywhere. We could actually access within the if. It's just that if we create a variable in a method, it can only be used in a method. If we create a variable in an if block or in a for loop or any type of loop, it can only be used in that loop. Okay, that is super important for you guys to remember. More on access modifiers. Access modifiers determine how the variables in your code can be accessed and used. It is basically designed to prevent programmers from inadvertently accessing and changing data that you don't want them to change. So the default access modifier is private. So if you don't put anything there, the variable, the method, the class, they become private. And private encapsulates the data and it basically hides it from outside programs because they cannot access that data. And that is part of object-oriented programming. We are going to be working a lot more with this in chapter 9. The other type of access, there's several, but public access is also quite popular. Public is kind of the opposite of private. With public, you want to give people access to methods or to variables. If something is public, that means that other programs can use it. So the purpose of making a class or a method public is to share it with other programmers. And you do have to purposefully make it public because the default is private. So to make it public, you have to put the keyword public in front of the namespace. You'd have to put it in front of the class. You'd have to put it in front of variables. You have to put it in front of methods. And if you don't make something public, by default, it is private. Okay, so here is a class and a method that are not public. Actually, it's a namespace, and I have now made them public. So this is public, and this is public. If you wanted to access a class or a method that were public, what you'd have to do is you'd have to use the namespace a dot, the class name a dot, and then the method name, and you'd also need to send it some parameters. So if the namespace was my namespace, the class was my class, and the method was print, this is how I would have to access it. And then I would pass along whatever parameter required. Few things to remember is if you make a class public, that does not make the methods inside the class public. To make your methods public, you have to put the keyword public in front of them. Anything you are intending on sharing with other developers, you explicitly have to make public. So I do have quite a few examples here, and we will be dealing a lot with this when we get into chapter 9. So we've got a namespace called Access Madness, and I've got a class. I am private, and it's private because there is no access modifier. And I've got a main method that is also private. Then I have another namespace. I am accessible. And I made the class public. I made the method public. Because the class and the method are public, I can access them from this little section of code. So this section of code is private, but because this is public, I can access it. So to access it, I have to use the namespace. I have to use the class, and I have to use the method. And the class and the method have to be public, okay, or I can't access them. Okay, and you can actually copy and paste this and run it too. So I made a comment and then I passed it to the method down here that printed it out. Method is in completely different namespace and class, and I could do that because they were public. And I made these examples simple so that you guys could see how they work. So here I've got a namespace called Night Out, and I have a class called Fun Night Out. And here's my main method. These are private. I have a class called Dinner, but you'll notice I have a public method here. Class called Movie, and I have a public method. Okay, so within main, I can call the public method. What I need to do is use the class, a dot, and then the name of the public method. Okay, and in both Dinner and Movie, I have a public method called Talk. So I can call it because they're public. And then that is what it looks like for output. Okay, so you guys can kind of look through the last example. It's similar to the other ones. And we will be working a lot more with access methods in chapter 9. So this is just a little introduction to them.